So hello everyone, welcome to CodeSwift. So this is the second part of the Java memory management, which is usually asked during the interview. As we have covered in the earlier section, so within the stack there is a reference and object is getting created on a heap and a reference is getting maintained over here. Just to add to this, on the heap space there is a string pool space as well. I haven't considered the string concept yet. There will be a separate video for that, but just for your understanding I am just letting you know. Okay, so now let's get back to the garbage collection concept. Okay, so there are two types of garbage collector executions that happens for the memory management. One is minor garbage collector and the second one is major garbage collector. And if you see, there are the heap space is divided into two parts. One is the young generation, and the second one is old generation. And there is one more non-heap space, okay, that is a after Java 8 we are calling it as a meta space. So whenever we define any static variable in any class, so those will be defined within this meta space. Whatever objects or whatever the primitive type variables that we are defining, those will be created in meta space. Okay, right now we are not concerning about it. So we will understand the difference between the minor GC, minor garbage collector, and the old garbage collector. So let's assume I have created these four objects T1, T2, T3, T4. Okay. So first time when those gets created from any function or anywhere, then in that case those will be created in the hidden space T3 and T4. Okay. And there will be an age associated with each object. Okay. So there will be an age. So in this case it will be 0. Age will be 0. Okay. For simplicity I am just maintaining it over here. Okay. So suppose let's assume after some execution the reference to T1 is lost, okay, in the sense it is deleted. Then in that case when minor garbage collector will be executed, then in that case my T1 object will be deleted, okay, and then my T2, T3, T4 survived that minor garbage collector, okay. Then in that case what will happen? I will just, for understanding, I will just remove it from here. So those three objects will be moved to survivor space 0, T2, T3 and T4, and their age will be 1. Okay. Now let's assume again after some time, let's assume reference to T2 is lost. Okay. In that case T2 will be deleted. So I am just simply removing it once that is done, and then T3 and T4 will be moved to survivor space 1. So this is within young generation, okay, this is the whole young generation. Within that we have survivor space, okay. This T3 and T4 will be removed from S0 and those will be moved to S1. T3 and T4 will be, and their age will be 2 in this case. So ideally in JVM there is always a age associated with each object. We simply call this as a age threshold, you can call it. So whenever that age threshold is reached, after that if any object survives the garbage collector, in the sense minor GC, then in that case it will move to old generation. So in our case, for simplicity, let's assume our that threshold is 2. Okay. So let's assume again after this after some time my reference to T3 is lost, okay. In that case my T3 object will be eligible for garbage collector, so it will be removed from memory, heap memory, and T4 till survived and its age became 3. In that case, as our threshold we have defined it as 2, so T4 will be moved to old generation. And during this time, by this time, let's assume we defined another one more object, let's assume T5. Again it will follow the same cycle. T5 will be created in the hidden space and its age associated with it will be 0, and it will follow the same cycle. So minor garbage collector, it usually happens very frequently to manage the memory within this young generation space, but the frequency of the garbage collector which will act on old generation, that will be a major garbage collector. So again that reference will be so again it will get executed only on the old generation objects, and the frequency of major GC is little bit less compared to the minor GC. So this way efficiently the objects will be moved here and there, and the algorithm that is used by JVM for this memory management is called as mark and sweep algorithm. So mark and sweep algorithm will be used by garbage collector. So again, if any of the object is marked for deletion, it will be removed. If it still exists, then it will be swept to a different survivor space. So this way the life cycle of an object moves from hidden space to survivor space, from survivor space to old generation, and it can stay there as far as the reference is there for reference associated with that object. That's it for this video. Thank you so much.